Hello, everyone. In this session, we'll understand the framework overview in Onfinity. We are going to cover the overview of the framework, understand the technology being used, and cover the architecture of the framework, which is the model-driven architecture. We'll also cover the application dictionary, different user interface elements, which are available in Onfinity, and how to extend the Onfinity framework for your customized applications. We'll start with the overview of the framework. The Onfinity Application Development Framework is an open-source and ready-to-go platform. If someone is developing a custom business application for their company or their customers, they can use the Onfinity framework and develop their own business applications or the functional features. In the Onfinity framework, we provide the module-level approach. With this approach, users and customers don't need to create the application from scratch. The framework is available, and they can develop their modules on top of it. The Onfinity framework offers features to develop modules and business apps. It can save coding time, as the framework and base features are already available. Developers can build their own modules on top of the framework. Users can create their own modules and deploy them via the Onfinity market. There is a marketplace available for the Onfinity framework, where users can download modules easily with a single click. The Onfinity market also offers versioning features, so you can release modules version-wise if there are enhancements later on for a particular module. Now let's understand the technology being used for Onfinity. Onfinity is based on HTML5 and developed in ASP.NET MVC technology, using C# with Visual Studio 2019 as an integrated development environment. There's a basic concept of the MVC model, where the browser sends an hypertext transfer protocol request to the controllers. The controller connects to the models, which is the business logic layer. Views and partial views are available on the client side, connecting to the controller and sending the response to the browser. The Onfinity framework is a SPA or single-page application. All the necessary code, HTML, CSS files, are retrieved on a single-page load. When a user enters the URL of the Onfinity instance in the browser, all the necessary files are downloaded onto the client side on a single-page load. Further asynchronous JavaScript and extensible markup language calls will occur if there are save, update, insert, delete, or other operations happening within the application. The client-side user interface is based on HTML5, JavaScript, and CSS. Onfinity supports multiple browsers and devices, and you can run the Onfinity application on different browsers and devices. Hosting of an Onfinity file is done on Internet Information Services or IIS. Internet Information Services is required to host the Onfinity application. The hosting files contain required libraries, areas, and other components, which connect to the database. As we have mentioned, Onfinity offers a module-level approach handled with the concept of areas. There will be different areas for the modules, which will be available in the marketplace, and which users can develop and deploy. If we understand the architecture of the Onfinity framework, on the client side, we have runtime libraries, a desktop manager, and view manager classes. Role-based security, encryption, views, and partial views are present. Data is passed from the client side to the server side in JSON format to the controllers. On the server side, we have the web services layer and a data dictionary that handles the user interface and the back-end logic of the framework. Role-based security is also available on the server side to control the data displayed to the user and who can access the application's data. Different business logic layers are included. A persistent object handles saving, updating, or deleting data throughout the application. Converter classes are available for the database, including Oracle and PostgreSQL. ADO.NET classes are also present, which connect to the database. On the server side, we also have the Onfinity market, from which users can install modules. Then we have the vServer component. Different components of the vServer include a workflow processor, alert processor, scheduler, account processor, and request processor. These are responsible for their individually assigned tasks for the jobs scheduled in the system. As mentioned, we are following a model-driven architecture. In most applications, when developers design screens, whether there are 10, 20, 50, or any number of screens, they need to design them by code and test each screen one by one. This can be time-consuming and could lead to inconsistencies in look and feel, as well as functionality. Onfinity simplifies the task by using a more advanced concept of a central active data dictionary. Screens are generated at one time from the data dictionary. Whatever rules or configuration is done in the application dictionary, the screens are generated on the fly. There is no need to test each screen because the rules are configured. All screens will have a standard set of menus and other actions, which are customizable according to screens. Developers define the rules for how the screen should display, the conditions for displaying the screen to the user, and how the fields are aligned. This is done by configuration in the application dictionary. There is no need to write code to display the screens or fields to the user. Onfinity's application dictionary is an integral part of the application, understanding how to access data and how data is related. For example, foreign key constraints and parent-child relationships across tables are handled by the data dictionary, which is configured so code isn't required. The application dictionary also contains definitions for the data entity, such as data types, the type of control displayed on the user interface, validations for data displayed on the user interface, and how data or controls are displayed on the screen, which includes labels, reports, help, display sequence, the position related to other fields, and display rules. It's possible to control which fields are displayed to the user on the user interface using this data dictionary. The application dictionary also manages security and access control rules. As we saw in the architectural diagram, role-based security controls data based on the role and user access. This enables authorized users to add new tables, screens, and additional fields to existing screens. You can create customized screens from scratch by configuring rules in the application dictionary, and you can also customize existing screens. If you want to add one or two fields to an existing screen, you can add those fields to the existing screens. These are all configurable, and later, you can package those screens in a module and ship that module to the Onfinity market. It manages common actions and their visibility on the screen. It also manages data visibility according to access, and parent-child relations between data according to the defined rules. It also enables authorized users to build multilingual and multicultural applications. Based on the login language, screens are displayed in the language used to log in. Let's understand the user interface elements. Onfinity provides two main user interface elements, screens and pages. Screens are auto-generated user interface elements. The layout design of the screen is generated by the application dictionary, based on the rules set by the user. As per the user request, screens are generated on the fly by the application dictionary. As we mentioned previously, screens are designed based on the configuration done in the application dictionary. Users can define screens on this Onfinity framework and deploy them via the Onfinity market. Now, let's cover the screen user interface element. The screen is an interface for users to enter data, entities, or transactions into the system. It can be a master entity or a transaction entity. Data is entered onto the screen based on the user's requirements. Screens are defined according to the requirements, and based on the configuration, the screens are displayed to the user. It can contain a single tab or multiple tabs with labels or fields for the user to input or output data. At least one tab is required on a screen, and users can have as many tabs as they want. Users can also set rules to generate screens with more than one tab according to their requirements. For screens, users do not need to write any code. It is automatically handled by the Onfinity framework based on the configuration done for a particular screen. Screens generated by the application dictionary cover basic functionality like adding, updating, and deleting records, as well as more advanced functionality like search, advanced search, attachments, chat, letters, and email. These actions, such as attachments, chat, letters, and email, and much more, are configurable and customizable screen-wise. Additionally, add, update, delete, search, and advanced search functionalities are standard features for all screens. Users can use the inbuilt features of the Onfinity framework for the screens they have created. Now, let's cover the examples of certain screens already available on the Onfinity framework as standard features. We can understand the sales order screen. This screen has a menu section in the toolbar on top, a right action panel on the right-hand side for actions such as chat, attachments, email, and short message service. These are configurable based on the screen, and you can define these actions as a user. The center panel is the content area where users enter all the fields to create a transaction or master data in the system. Then, there's a taskbar where all these details are displayed at the bottom of the screen. Then, there is another kind of screen. For example, a sales order might have a header panel along with the information we've already seen on the sales order screen in the previous slide. In this header panel, you have basic information for the transaction, such as who the customer is and what the order number is. You don't have to check the fields and search for a particular or basic field that the user wants to see. You can keep those fields on the header panel so that users can easily access the screen with the information already available on the header panel. Another screen, format, or layout example is user management. This has the same format we have already understood. There is a standard set of menu toolbars available on all screens, a standard search functionality, and an action panel. It has stepwise tabs where the user management screen has user information. You can link a role, and then you can click on the Access Organization. There's a Next button to access additional tabs. These are basic examples of the screens we have already understood. There are many more screens available in the standard features with a user interface. We just shared a few examples of the screens with you to give you an idea of how the user interface element for a screen looks. Another user element is pages. A page user interface element is needed when the user requires a different layout and doesn't want a menu section or a right action panel. In this case, they want to design the page according to their requirements. The layout of the page is not auto-generated by the application dictionary, as we saw with the screens. Here, users design the layout from scratch and assign it to the application dictionary. The application dictionary provides an option and blank area, where users can create their own controls with the help of jQuery, HTML, and MVC. To create a page, users should have a basic understanding of how to code in the Onfinity framework and some basic knowledge of jQuery, HTML, and MVC. The application dictionary opens the page layout as per the user request. Whenever a user searches for a menu item for the page, they enter that page and it opens. This is an example of a page created with the help of jQuery, HTML, and CSS. As per the requirements, this is the payment form available in the Onfinity framework as a standard feature. As you can see, it has a slightly different layout from the screens we have already seen. It has different controls on the user interface, and there are different action buttons where users can click any button, and whatever code the user has written for this page executes in the system. Now let's cover how to configure and extend the Onfinity system. Without programming, users can configure the user interface elements. They can create screens, add labels and fields to the system, manage actions based on the requirements for a particular screen, show or hide actions, and configure the language for the user interface elements. Then, users can configure reports, dynamically create reports with the Report Composer page, and format reports using the Onfinity Report Composer. To extend the Onfinity application, users can add new fields. Database columns should be created in the database schema. Users can add new entities, and database tables can be added via the user interface and configuration. They don't need to go to the database directly. From the user interface itself, they can create the tables in the database, add new data validations and default values for a particular column or field, add new workflows, change security rules, call the .NET classes at runtime through processes or jobs, add new dashboard charts, reports, key performance indicators, and views by configuration, add new jobs, and add new information screens to have a user interface. Now, we can understand the advantages that Onfinity offers. Also, we can understand what makes Onfinity scalable. We have a deployment architecture where there can be multiple application servers and a scalable database, which is Oracle. Server-side processing is also included. Background jobs can be run via the vServer and the scheduler. You can schedule jobs in the background, which can execute periodically based on the schedule you've defined, which is configurable. Users can deploy schedules on different types of vServer components on different hardware, which is another possibility. And we can understand what makes Onfinity extendable. The application dictionary, which we have already understood, allows users to create their screens, fields, reports, and menus in the data dictionary, which is configurable without writing code. Then there is workflow configuration. Users can define workflows, and we have a workflow composer from the user interface with a drag and drop feature. They can create their workflows from the workflow composer. Alerts are also available in the system, which is configurable. There is no need to write code for that. We also have a comprehensive set of web services, with standard web services available in the Onfinity system in cases where users want to connect a third-party system to the Onfinity framework. That concludes this session. Thank you for attending.